Intertech is a commercial design company based in Hull that has made a staggering 93% energy saving in their new building. The company delivers creative automotive, hotel, leisure and retail commercial environments. They've been doing this for over 20 years in more than 34 countries and have a customer base that spans 6 continents. Their director, Andrew Fenton, is passionate about the global challenge of reducing energy consumption that faces us all, and has demonstrated this commitment by investing £2.1 million in a sustainable building which makes the most of practical, cost-effective solutions that help speed up the process of meeting these environmental challenges. Utilising vertical axis wind turbines, solar panels, energy-efficient lighting and rainwater harvesting, he has already made a 93% saving on the energy costs and intends to be off the grid by the end of 2012. This is how he achieved the savings, and we can all utilise one or more of his methods.
My name is Andrew Fenton and I'm the director of Intertech Media UK Limited, which is a commercial design company doing retail, commercial and public spaces. So we do interior design. When we designed this building, we focused on the renewable sector to try and get it as energy efficient as possible so we could use it as a benchmark to show our customers. The main area for us, obviously, from mainly with our customers, is obviously retrofit elements, which is converting the lighting over to energy efficient lighting, and then obviously with things like new builds to do with the heating systems, the renewable energy on solar panels and wind turbines, and just packaging the whole thing together to see which is most viable. We have a rainwater harvest system which we designed ourselves purely because the ones that are sort of relatively on the market are external and they need electricity to pump them back into the building. And majority of them are on a commercial level with a 3-phase water pump, so they do use quite a lot of electricity to pump the water back into the building. So we thought, well, we'll design our own, which is initially gravity fed, so obviously doesn't need any electric, and also because there's no pump pumping any water, the water stays relatively clean. We use this rainwater harvest system for all the toilets and one cleaner's sink. We've got a 93% electric and gas saving from our existing premises to these premises. So effectively we would have had obviously an industrial building, quite large, 18,000 square foot. We would have, under normal operational hours with computers and the distribution area, we would have roughly been about £22,000 of utility bills to run that environment. Within this particular building, it's come down to £1,200. So we've actually got that, and that's a mixture of electric and gas. So for us, it's been a tremendous saving. There's nothing that we've done here that couldn't be implemented into an existing building.
But of all the systems that you've adopted here, what do you think are probably the most sensible for village halls to look at?
Probably is to look at the lighting, the use of the building in general, how the lighting is used, how it can be switched on and off effectively, and also any form of generating any renewable energy such as solar panels, and then again with heating, looking at the existing boiler and see if there's any way of actually improving how the boiler functions, be it on additional thermostats, being able to switch things on and off a bit easier, just the managing of how the heat is used within that type of a building. Our goal is later on this year is to try and get the building to come off the grid, and we're working on that at the moment with a number of smaller turbines that work in lower wind speeds, and it's those turbines, which are very small turbines, they're only basically a metre diameter, but it's tied in with some form of storing our own electricity by the aid of a number of batteries, and then looking to see how we manage our energy consumption to take full advantage of storing our electricity. And currently at the moment we think it's achievable. So this meter currently at the moment shows that this area is using no electricity at all, and it's connected to the consumer unit. So when we actually switch the lights on, you will actually get a reading of what power this area is using. So at the moment it's gone to 1.4 kilowatts. So effectively 1.4 kilowatts per hour, which will cost you 14p an hour to run, £3.38 a day, £23 a week, and for 1 month £100, and for a full year £1,243. But that's based on if the lighting was left on 24 hours a day. So obviously if you're only going to use, say, a typical 8-hour day or 12-hour day, you could half that sum. So that sum would go down to £500 for the year to run this environment in lighting. There's 108 lights in this area as a typical sort of retail showroom, and effectively it's using 1.4 kilowatts per hour. So based on a retail environment. So if it was a public space, it would probably be lit at half that. I would say probably 500 watts. So effectively, a typical public space would probably cost around £200 a year to run, which is a phenomenal saving. Obviously based on this type of lighting, this LED lighting.
Right, which is the good guy and which is the bad guy?
The metal halide tungsten halogen light is obviously, it gets very, very hot. 2,000 hours lifespan, compared with an LED, that's 50 watts, and that LED is 2 watts. So effectively you can run 25 of these for one of these. Cost difference on pro rata, I think you can pick these up for sort of £2, £2.50, whereas these are can it be anything from around about £8 to £10. So that's the difference. I mean, in theory, you shouldn't have to replace that for 25 years, whereas that you'd be replacing about almost yearly. So if we look at sort of our building, which uses, when it's fully occupied, around about 5 kilowatts, between 4 and 5 kilowatts an hour, based on 18,000 square foot on 3 floors. These 3 heaters use more electricity than our whole building does when it's fully operational. So if you were to put these on, that's immediately gone up to 5.8 kilowatts just on these 3 electric heaters, around about 2 kilowatts a heater. So that's using at the moment half a kilowatt than our whole building is at the moment. So to give an idea, that would be costing you almost 80p an hour to run, £19 a day, £130 a week. But obviously that's if they're on 24 hours a day. But even if you half that, so if you have them on 7 nights a week in winter, you're going to be looking at near almost £70 a week. None of the pipes within the infrastructure of the building are insulated, because we want the heat to move around the building and act as like an ambient heat. So as the heat travels around the pipes, around the fabric of the building, we want it to give heat out. What we don't want is all the heat to be on insulated pipes and then it all being forced to the point of a radiator. We want the pipes that are en route to the radiator to be able to give out heat in the whole fabric of the building. So with this particular one, we want a little bit of heat into our distribution area. So the heat comes from the boiler, hot water pipes come out first, ambient heat comes into this area, and then it goes back into the office accommodations to run around the radiators. It just raises this temperature enough to become sufficient enough for a working environment. The smaller turbine generates 1.5 kilowatts an hour on an average wind speed, an average windy day, not gale force winds, but just an average typical windy day. You'd roughly get about 1.5 kilowatts. So we're using between 3 and 4. So wind prevailing, that's generating half our power for the building per hour.
Is that more effective than if you like, the standard turbine, the one that we're perhaps more familiar with?
These are specifically designed for built-up areas. So obviously a small site or a small area, there's no zone that has to be clear. You can park underneath them, and with them being like an egg whisk, they don't pose a risk for people walking underneath. So for an application where it's built up, these are perfect, and they're a lot more cost effective to maintain. Normally, typical good wind is about 5 metres per second, which is about 12 mile an hour winds, 10 mile an hour winds. That would supply enough power to run a typical village home easily, because we're getting half the power from it for this building, and this building's 18,000 square foot. It does use a little bit of electricity to generate the blade to when it first starts going, so not quite as green as solar panels. The solar panels obviously come late evening, it's gone dark, whereas if the wind is active, if it's wind prevailing, you're going to get power basically 24 hours a day. We're confident that, looking at what we're trying to implement over this next year, we do think that it is possible to try and get a typical commercial environment producing its own electricity.